Hey guys, in this video we're going to learn about the Coulombs Law. The Coulombs Law explains the electrostatic force of attraction and repulsion between two charges. This law is named after a French scientist, Charles Augustin de Coulomb. The SI unit of charge, Coulomb, was also named in honor of Charles Augustin de Coulomb. We know that there is a force of attraction between unlike charges, and there's a force of repulsion between like charges. So if we had a positive and a negative charge put together, they would attract each other, and a negative charge would repel each other. Coulomb was trying to figure out, is there a law that governs these forces? So he conducted a lot of experiments using this apparatus called as the Thorson's balance to figure out any sort of relationships among these forces. And what he found was that the force of attraction or repulsion was directly proportional to the magnitude of charges. So if the charges were of magnitude, let's say Q1 and Q2, then the force was directly proportional to Q1 multiplied by Q2. What he also found out was that there was a relationship dependent upon the distance between the charges. And what he found through experiments is that the force was inversely proportional to the square of the distance between the two charges. So if the charges are at a distance r from each other, then the force is proportional to 1 upon r squared, or 1 over r squared. Now if you combine these two proportionalities, we get a single proportionality, which is the force is proportional to Q1 times Q2 divided by r squared. Now we can convert this proportionality into an equation by bringing a constant. So the force could be equal to K, which is a constant of proportionality, times Q1 into Q2 over r squared. And K is known as Coulomb's constant. Now this equation constitutes the Coulomb's law. Coulomb's law states that the force between the two charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the distance between the two charges. Now, what does that mean in real sense? So let's say if there was a charge on the left of magnitude Q1 and a charge on the right of magnitude Q2 at a distance r from each other, there was a force F. Now suddenly if I change the magnitude of the charge Q1, almost double it, what's going to happen to the force of attraction? It's also going to increase, right? If I increase the size of Q2, then the force will further increase. Now what if I move the charge Q1 further away to the left and increase the distance r? What's going to happen to the force? The force is going to, yes, reduce. If I move the charge on the right hand side further to the right, increase the distance even more, the force will further reduce. The next thing we want to consider looking at is the definition of 1 coulomb. How much is 1 coulomb of charge? The way 1 coulomb of charge is defined is that it is the amount of charge that gets transported in a current of 1 ampere in 1 second. What that means is if you had a wire which was conducting 1 ampere of electric current, and if you had a stopwatch and you timed it 1 second, then exactly in 1 second, there will be 1 coulomb of charge transported through that given wire. So here's a fun fact for you. Do you know how much charge does 1 electron have? Well, I'll tell you the answer. It's approximately negative 1.602 times 10 to the power of minus 19 coulombs. Now that is negative 0.000000000, well, lots of zeros, actually 19, and then 602. So that's a very, very small charge. So you're not that big, you big fella, you're really tiny. So now can you solve this? How many electrons need to be transported in 1 second for a current of 1 ampere? Now you got to do some math here, but see if you can figure this out. I think I've given you all the information and the equation for you to find the answer. So post your answers in the comments section below. And if you like this video, go ahead and hit the like button so that it will continue to motivate me to make more such videos.